All right, today we're going to sharpen a really powerful mental tool. It helps solve a super common and pretty tricky type of puzzle. It's all about how to count things the right way, especially when groups overlap. So let's just dive right in.
Okay, quick question for you. In a group of 27 friends, you find out 15 are dog lovers and 12 are cat people. So, how many people like at least one of these pets? I mean, the answer seems obvious, right? 15 plus 12, that's 27. But is it really that simple?
You know, if you thought 27, you actually just fell right into a very common logical trap. The real answer is something different, and the reason why, well, it reveals a pretty brilliant principle for thinking more clearly about groups and numbers.
And that trap, it has a name. It's called the double counting dilemma. And honestly, it's a simple mistake our brains are just kind of wired to make when we're not paying close attention.
Double counting is exactly what it sounds like. It's the mistake of counting the same things more than once. So when we added the 15 dog lovers and the 12 cat lovers, what about the people who love both? We counted them once in the dog group, and then we went and counted them a second time in the cat group. That's the mistake right there.
So, how do we fix this? Well, that brings us to the solution, a really simple formula that just elegantly solves the whole problem. It's really the heart of this whole inclusion-exclusion principle.
To make this crystal clear, let's switch to a tastier example. Imagine a survey about food. We find out that 20 people like pizza, 15 people like tacos, and 8 people, the true food champions, they like both.
Okay, so let's build our calculation, step by step. We start by including the first group. That's 20 people who raise their hands for pizza. Simple enough. Next, we include the second group. We add the 15 people who love tacos. But hang on. Right now, our total is 35, and we know that can't be right. We've just fallen into that double counting trap all over again.
And this is the brilliant solution. This is the exclusion part of the principle. We have to subtract the overlap, those 8 people who like both pizza and tacos, because we counted them twice. By subtracting them once, we make sure they're only counted one time in the final total.
And here it is, the principle in its formal glory. The number of people who like either pizza or tacos is the number who like pizza, plus the number who like tacos, minus the number who like both. For our survey, that's 20 plus 15 minus 8, which gives us the real total of 27 people. It's just that clean.
Okay, so you've totally mastered 2 circles. But let's be real, the world is often a lot messier than just A and B. People's tastes and behaviors overlap in all sorts of complex ways. So let's level up the challenge and see what happens with 3 overlapping sets.
Whoa, okay, now that formula looks incredibly complicated, and yeah, it kind of is. You add the 3 main groups, then you subtract all the two-way overlaps, and then you have to add back the very center. It's a lot to remember. But here's the cool part. There's a much more intuitive way to solve this.
Yeah, forget memorizing that monster formula. Most pros use a simpler strategy, and it's called the center outward method. You just start with the number in the absolute middle, the group that likes all 3 things. Then you use that number to figure out the pieces that overlap between just 2 groups, and finally, you can figure out the outer parts. It turns a messy calculation into a simple step-by-step puzzle.
So this is a fun mental exercise, sure, but why does it actually matter? Let's zoom out a bit and connect this to the real world, because it's a foundational idea in some really important fields.
This is so much more than a shortcut for brain teasers. It's an absolutely vital tool for figuring out the odds in probability. For data scientists, it is essential for getting accurate numbers. I mean, think about it. A market researcher can't count a customer who uses 2 of their products as 2 separate people. And if you ever want to get into combinatorics, the really powerful math of counting combinations, this is pretty much step 1.
So the crucial point is this. What we've learned today is that accurately counting the number of items inside a set of groups is the absolute foundational skill you need before you can even begin to understand all the complex and interesting ways those groups relate to each other. And that leaves us with a final thought. Today, we figured out how to count what's inside the circles. But what if we wanted to count all the possible pairings or relationships between the items in different sets? Now that's the next level of this kind of thinking, and a good question to ponder.